Hello and welcome to the next in this series of videos. In this one we're going to look at the single variable t-test using Excel. As before, I have pre-populated a spreadsheet with some data. So just to explain and set the scene, what I have here is the number of sales made on each day over the course of a month. It's a 20-day month with 4 weeks. The business is only open Monday to Friday, and I have week 1, 2, 3 and 4, and then Monday, Tuesday through to Friday for each of the 4 weeks, and then I have the number of sales entered against each day in column C. And what I want to do is I want to compare this to last year's average or mean monthly sales, which you can see down here in cell C24 was 175, and I want to work out if there is a difference and if that difference is statistically significant. So how do we do it? Well, we have a little bit of a problem because Excel doesn't actually have a single variable t-test function. So there are a number of ways that you can proceed. Firstly, you can do it in what I'm going to term the hard way. This is actually the proper way, and it uses this formula down here, t equals all of that. And this is actually the formula for a t-test. And here, in column G, I've got all the figures that you actually need to perform that t-test and come out with a result. And it starts off up here in cell G6 with the population mean, in other words, the mean number, or the mean that we're interested in, the mean number of sales per month last year, which in this case was 175. We also need to know the number in the sample, which in this case is the number of days, n, and we need to know something called the degrees of freedom, which is n minus 1, which is obviously going to be 19. We then need the sample mean, in other words, the mean of our number of sales over here, and we do that by using the average function in Excel, just the same as we did in video 1. And you can use the formulas bar for that and the insert function, or you can just type in equals average and put in the range of cells C2 to C21. And that's where it starts getting complicated, because the next thing you've got to do is work out the bottom part of the formula using the square root and various other data, the sample mean and so on and so forth, and there's the formula. So that's the next part, and then you've got to work out the standard deviation of our sample. Slightly easier because it uses the standard deviation function that we've already used. Again, you can use the insert function for that and calculate that, and then you have to calculate the standard error, and there is the standard error calculation. Cell G13, which is the one above the standard deviation, divided by the square root of G7, which is the number of days, the number in the sample n. And then you divide G12 by G14. And then Excel does actually have finally a useful function, which is to calculate the p-value, which tells us whether the value is significant or not. And if it's less than p.0, p is less than 0.05, which it is in this case, it means that we do actually have a statistically significant difference. Okay, so that lot probably gives you a headache. It gives me a headache as well. It's not the easiest of things to do, and I certainly would struggle without this spreadsheet that I actually set up a few years ago to help me with it. And you can use this to calculate the t-value if you want, but you would need to put your data in here, and obviously if you haven't got exactly 20 pieces of data, in other words, if your n is not 20, you would need to go through and adjust the data ranges for all of the different cells where the data range is actually used. So you've got G7 where we use the count function, we've got G11 where we use the average function, and so on and so forth. So yeah, you could use it. I'll leave it on the spreadsheet. You can have a look at it, you can have a play around with it, do what you wish with it. But personally, I think maybe there is an easier way. So let's start looking at alternatives. Well, the second method is to do a z-test, which is a slightly different calculation, but again, it tells us if there is a statistically significant difference between the set of data that we're looking at and the mean from last year, in this case, the mean monthly sales for last year. And you can access that test again through the insert function and just typing in z-test, and it will come up with the options, and there are actually two options. If I just put a space in there, z.test and z-test. I used the z.test function there, and the same there, and the difference is I've calculated the standard deviation as well, which gives you a more accurate result. But again, it does fall a little bit short. In fact, Microsoft acknowledged that because they've actually provided a link telling you how to calculate the p-value for a z-test. Strange that they don't put it in to the function that they provide with the Excel package. And there it is. If we look up at the function bar, you can see it. 2 times min, open bracket, z-test or z.test, so on and so forth. So it's not straightforward. Again, you can do it. That's not a particularly difficult formula to type in, but again, it's not exactly easy. So that's the z-test. Again, I will leave that on there for you to have a look at. Have a look at the link, have a read, see what you think, take a decision what you want to do. Method 3 is suggested by a chap in this link down here. So again, have a look at that link and see what you think. Now, how does this little cheat work? Well, what it actually does is it does a slightly different test, one that is actually reliant on having 2 sets of data. So we've got our first set of data here, which is the sales, number of sales for this particular month that we're interested in, and we need to create a second set of data based on the average monthly sales for last year. And we need basically the mean of that data to be 175. So quite simple, I'm just going to create a new column here, mean of last year, and then I'm just going to put in 175 twice, because obviously the mean of two 175s is 175, and that is all we actually need to add in to actually calculate this test. And then I'm going to move the cursor up to G1 and actually do the test. Now, to do that, what we need to do is we need to select the data tab rather than the formula tab this time, and once you've selected the data tab, go over to the right hand side and click on this data analysis button here, which only comes up if you've already installed the Excel data analysis tool pack. I did create a video for this, so if you haven't installed it, might be an idea to install it as soon as this video finishes. Click on that and it brings up this little dialog box, and the test that we want, it's already highlighted here, but yours might not be. It's the 2 sample assuming unequal variances t-test. So highlight that and click on OK, and it brings up this dialog box. Now, the first one, variable 1 range, is this number of sales here. The second one is the variable 2 range, in other words, the 2 175s. You've got the hypothesized mean difference, I leave that, I leave the labels out. The alpha or p-value or significance test is set at 0.5, and then you need to change the output range. You can have it on a new workbook, a new worksheet, or the output range, in which case you just select on there and you click the cell where you want the results to appear. So I'm just going to click on G1. You see that it's populated there. Click on OK, and Excel does the work for you. And there is the t-test. It's variable 1. You can see that the mean is 180.8, which is calculated from these figures. You can see variable 2, mean is 175, which yes is 175 there, and then it goes on to work out various different options and then comes out with the t-stat there, and it comes out with two p-values, one for a one-tailed test and one for a two-tailed test. We want the two-tailed test because of course ours could be above or below this figure of 175, and that basically is how you can calculate a t-test result. But as I say, it is a little bit of a cheat. It's not exactly the right thing to do. So the fourth way is actually not to use Excel, it's to use SPSS. Excel does have its limitations. It's a very good package at doing certain things, such as, which we've already looked at, producing charts. Excel's far better than SPSS at that sort of thing. But SPSS is specifically designed to undertake statistical tests, and it does that very, very well. So there will be some circumstances where you might want to use Excel, but actually, such as this, when you want to do a single variable t-test, it actually presents you with a few problems, because you've either got to go through something pretty horrendous like this to actually produce your result, or you've got to do an alternative test which perhaps isn't as good but it's still got problems, or you've got to do a little cheat. So sometimes it might just be best to use SPSS. So I think if I were confronted with this, to be honest with you, I would do either method 3 or method 4. I would either use the little cheat or I would use SPSS. I'm fairly conversant with using SPSS. You may not be so happy, so don't be afraid to use this little method, this little alternative method here. And as I say, there is a link there that you can actually look at it online. So that's it for this video. Thank you very much.